Hello my dear EAPCET aspirants, welcome back to NEET WORLD. So today we will be discussing the chemical bonding, particularly valence shell electron pair repulsion theory will be discussed in this particular session. Okay, so I will be covering both theory and as well as PYQ questions related to that particular topic, and along with that I will be discussing dipole moment, hydrogen bonding concept along with the questions. Okay, purely for EAPCET, highly helpful for you. So just stay connected with this complete session, then you will definitely learn something new in this particular session. Okay, yes, let's begin this session. Yeah, so here in the last class I have discussed about normally like Lewis dot structure, and then next what exactly formal charge related questions, formal charge, then next Fazan's rules, and the next VBT, and also hybridization I have discussed in the last session, and PYQs also covered in that. Okay, right, I hope you have watched the previous session also. Let's discuss this. If you haven't watched this previous session, you can go and watch in the playlist of this NEET WORLD YouTube channel. Just go through the playlist, click on the playlist, and EAPCET 2026 playlist will be there for chemistry, or otherwise go to the live session. There you will be having all the lives that I am doing from last 10-15 days. Okay, right. So look at this valence shell electron pair repulsion theory. So what is the use of this valence shell electron pair repulsion theory? So it helps us to calculate or to give the exact structure of the molecule, how the lone pairs should be placed along the atom around the molecule, and how the bonds are oriented, and how the bond angles will be changing due to the presence of lone pairs, what is their effects, factors affecting bond length, bond angles, all things will be discussed here. Okay, right. Let me give you the content here first. Yeah, so in the last class I have discussed till this sp3d hybridization. So let's continue with the same discussion here. So when do we get this sp3d hybridization? So compounds like having PCl5 or PF5 like that, no? Right. So look at this phosphorus here having how many valence electrons? 5 valence electrons, because it's having electronic configuration as 3s2 3p3. I hope you know the general electronic configuration of 15th group as ns2 np3 right now. So that 5 electrons you write it like this. After this how many surrounding atoms are there? 5. So 5, that's it. So 5 sigma bonds are formed. So 5 sigma bonds means you can say S5 now. So one is S, remaining 3 P's, and 1 D, sp3d hybridization. So with this sp3d hybridization, all 5 are sigma bonds now, then we will be getting trigonal bipyramidal geometry, something like this. Okay, so in this trigonal bipyramidal geometry, phosphorus at the middle and around 3 chlorines, which gives trigonal planar geometry first. Okay, and 1 chlorine above side and 1 more below side. Okay, like this. So now the bonds which are above and below are called axial bonds. These are, what is that? Axial bonds, and these are within the trigonal planar geometry called as equatorial bonds. Remember, when the surrounding atoms are same, having axial equatorial positions now, so axial bond length is greater than the equatorial bond length, and axial bonds are weaker than these equatorial bonds. Therefore when we heat this PCl5, what happens? These 2 weaker bonds are there now, they will dissociate to give, or they decomposes to give PCl3 plus Cl2 gas. So these are the products formed. So by this what we can say, axial bonds are weaker than the equatorial bonds. You can remember this statement. Okay, right. So I hope everything is going well here. Yes. So the next, tell me here, what if there are like there is sp3d hybridization, but only 4 bonds are there with 1 lone pair. So you can take the example of SiSCl4 or SF4. So in this case sulfur is having 6 valence electrons, so take 6 dots like this, okay, and chlorines are 4, that's it, with one lone pair. So how many we got? 4 sigma bonds with one lone pair. So totally 4 sigma bonds plus one lone pair. So totally it is 5 now. So 5 means you can say sp3 4 over, next one is D. Okay. So sp3d hybridization we got. Generally geometry should be, electronic geometry should be trigonal bipyramidal, but only 4 sigma bonds are there now. So using that 4 sigma bonds, so I am writing here, see this could be the structure with the sp3d geometry, but you know there are only 4 surrounding atoms with one lone pair now. Always place lone pairs with maximum angle of separation. See this axial bond here having 90 degrees angle. If you observe, this is 90 degrees angle. So do not place in that. See here we have, they are separated in the equatorial position as 120 now. So place any of these 3 positions. So I am placing in this position, so that we will get lone pairs here, and the next remaining atoms are 4, like this we will get. So this shape after placing this lone pair is called as, this is called as seesaw shape. What is that? Seesaw or distorted tetrahedral. You can say seesaw or distorted tetrahedral. Okay, hope it is clear. So always remember, whenever there is lone pair electrons in sp3d hybridization, try to place them all the time in the equatorial positions only. So similar example I am giving you with 2 lone pairs. Here we have one lone pair. With 2 lone pairs you can take this interhalogen compound BF3. Okay, so in this BRF3, not BF3, it is BRF3, bromine trifluoride. So now what happens here? Bromine is having 7 valency electrons. Take 7 dots, put 3 fluorine atoms and 1 lone pair, second lone pair. Like this we got 2 lone pairs and 3 bond pairs now. So totally 5. 5 means 3 sigma plus 5 are 2 lone pairs. So this is sp3d geometry hybridization, which gives us trigonal bipyramidal geometry, electronic geometry. So first of all write the electronic geometry, then you will get the structure from that. Write the electronic geometry. What could be the electronic geometry? Bromine in the middle, like this, like this. So what I told you, there are 2 lone pairs. 2 lone pairs should be placed in the equatorial position. See, these are 3 lone pair, 3 equatorial positions. So I am placing one here one lone pair and here one more. So that we will get lone pair here, and 3 other positions are occupied by fluorines. That's it. Like this. Hope this is also clear. Next, can you tell me what could be the structure and geometry for ICl2 minus? ICl2 minus. So just try this and tell me in the chat box, because there are many questions asked by giving it different interhalogen compounds, like identify their hybridization or identify their geometry or their structure, shape, like this they will mention. Hope you got complete concept on this and you can able to do now this, I hope. Next, when I have PCl3F2, what is the scenario here? So whenever you have electronegative atom, what will be the position of this electronegative atom and what will be the position of these chlorines? If you know the answer, just tell me in the chat box, comment. Okay, what is the position, whether it is positioned in axial or equatorial? What is the position of chlorines, axial or equatorial, after writing sp3d hybridization? Okay, right. Next. So we can also have this sp3d2 hybridization. sp3d2 hybridization will be seen when we have 6 atoms around a central atom like sulfur. Like best example here I am taking is SF6. Now tell me here, sulfur is having 6 valency electrons, surrounding atoms are also 6. So 6 plus 6 by 2, that is 12 by 2 means 6 again, 6 hybrid orbitals are what? sp3d2, that's it. Okay, it is sp3d2. So with sp3d2 you can write central atom sulfur, surroundings 6 atoms. After this, see you got a square planar geometry. So on this square planar you place one fluorine above side, one below side. So by joining them you will get a pyramid above side, below side. You can call this as octahedral geometry. What is that? Octahedral geometry. Place all fluorines in this way. Okay, okay. So this shape is what? Octahedral shape or octahedral geometry here. Okay. So in this octahedral geometry, sometimes we might be having 5 bonds with one lone pair. So that lone pair should be placed in the above side or below side, so that you will get square, one side only pyramid, other side lone pairs are there now, so no pyramid. So you will get square pyramid when we have octahedral geometry with 5 bond pairs, one lone pair. Hope this is clear. And the next, sometimes we will be having octahedral geometry like sp3d2 hybridization with 4 bond pairs, 2 lone pairs. So again the 2 lone pairs placed at above side and below side. Therefore we will be only remaining with the planar molecule right now. So the shape of that molecule is called square planar in that case. Hope everything is clear here, right. So the best example for that is XeF4. Okay, you can try it if you want, like 8 xenon 8 plus 4 12 by 2 is 6. The next sp3d2 hybridization with 4 bond pairs, remaining 2 are lone pairs. Okay, right. When it is sp3d3 hybridization, when it is sp3d3 hybridization, so you will be having example of IF7. Okay, so now tell me, for halogen iodine here we have 7 valency electrons will be there, right. So 7 plus 7 14 by 2 again 7 you will get. So it means sp3d3 right now. So if it is sp3d3 hybridization, so the geometry can be taken as, see, pentagon, we have a pentagon like this with 2 pyramids, above one, below one, pentagonal bipyramidalities. What is that? Pentagonal bipyramidal in case of IF7, whatever the molecule having this sp3d3 with 0 lone pairs, all of them are bond pairs. Okay, and sometimes we will be having sp3d3 hybridization with 6 bond pairs and 1 lone pair. So by placing this 1 lone pair, the structure will be becoming like you can remove one pyramid, so it will be pentagonal, like only one pyramid will be there. That can be also called as distorted octahedral. So where do we get that? Something like XeF6 we have, XeF6 minus. Okay, so what? XeF6, that's it, XeF6. So in this case we will get distorted octahedral geometry. Hope this is also clear, right. Now let us see some questions for understanding purpose. Look at this SF6, just now we have did SF6 means what I told you, it is octahedral sp3d2 hybridization, sp3d2 hybridization, and XeF6, just now I have given the example also. XeF6, what I told you here, xenon 8 plus surrounding monovalent atoms are 6 by 2, 7. So 7 means sp3d3. There should be 7 surrounding atoms, 7 monovalent surrounding atoms, but we have only 6. It means remaining one is lone pair. So by placing that lone pair, it becomes distorted octahedral. So this will be the Q1. And next, C6H6 benzene having all carbons sp2 hybridization, and PF5 will be having sp3d hybridization. Hope this is clear. P2, Q1, R4, S3. That's it. Fourth option will be a perfect answer for the question. Okay, right. Let us move forward. Few more questions will be there here. See, sometimes on a molecule, like in the last example, I mean in the previous session I have taken NH3 molecule and NF3 molecule, NH3 and H2O I have taken. In H2O, we have 2 bond pairs and 2 lone pairs right now, and in ammonia we have only 1 lone pair, remaining 3 are bond pairs like this. So due to the presence of these lone pairs, there will be maximum repulsions between this lone pair. So due to that repulsions, lone pairs will be placed as much as far as possible, okay, and also lone pairs will exhibit repulsions even with these bond pairs also. Therefore what happens, the maximum repulsions will be seen in case of lone pair, after that lone pair bond pair, and least is for bond pair. Therefore what happens, in order to avoid this maximum repulsions, the bond pairs are placed closely and lone pairs are having more space around them, okay. So what I told you, the repulsions will be maximum for lone pair, next lone pair, next bond pair. So option 3 here is suitable for this, okay, right. So due to that reason, what happens to the bond angle in this water molecule, due to avoid that repulsions between lone pair, the bond angle gets compressed. Therefore angle almost becomes 104.5 degrees, okay, and here instead of having 109.5 it is becoming 107, okay. What is the reason? Presence of lone pairs here, one lone pair in that case, two lone pairs in this case. Hope this is clear, okay, right. Next, so you can answer based on the explanation, you just answer me this question. Next here, can you answer for the hybridization of these three molecules? Very easy. NO2 means nitrogen now, yes, fifth group element, so 5 you take, 5 valency electrons as the 15th group, 5 valency, plus 1 is there, so remove 1 electron, by 2 you do, so that 4 by 2 means you have only 2, that is SP. So what is the hybridization in this case? SP hybridization. And for NO3 molecule, what you can say? So NO3 means nitrogen 5, minus 1 charge is there now, so add 1 electron to that, okay. Minus indicates addition of electron, plus indicates removal of electron, you can consider, okay, right. So that will get 6 by 2, that is 6 by 2 means 3, it means sp2 hybridization. Similarly for ammonia, you tell me 5 is a group number and valency, see how many monovalent atoms are there, 4 are there, plus 4, what is the charge present here? Plus 1, so it means we need to remove 1 electron, okay. So by 2, so that will get how much? It will be 8 by 2 means 4, so if it is 4 we can say sp3 hybridization. So we got sp, sp2, sp3 hybridization, option 3 will be your answer for this question. Hope this is also clear, right. See, can you answer me these three questions are there here on the board, just identify their hybridization in each of these cases. Guys, these are very useful, tell me here. SF6, just now I told you, if you do this 6 plus 4, 10 by 5, 10 by 2 means 5, 5 means what I can say, sp3 dehybridization. If it is sp3 dehybridization with 4 surrounding atoms, remaining one will be lone pair. Therefore, you will get seesaw geometry, seesaw structure, right. So in this case, xenon 18th group element, so 8 valency electrons, 2 surrounding atoms, by 2, 10 by 2 means 5. So 5 means simply you can say trigonal bipyramidal geometry, but in that we have 2 different positions, axial and equatorial. So what I told you, out of this 5, only 2 surrounding atoms are there, it means 2 bond pair electrons, 2 bond pairs, and remaining 3 are lone pairs. Where to place these lone pairs? In the equatorial. So place equatorial position with lone pairs, and these 2 axial positions with atoms, surrounding atoms. What are those? Fluorine above and fluorine below, that's it. So it's like a line now, see. So what is the shape of this molecule? Linear. What is that? Linear, okay. And can you tell me for this? See, xenon 18th group element, so 8 valency, monovalent atom, we do not have monovalent atom here, oxygen is not one, it's a divalent, it's not a monovalent. Next, fluorine we have 2, by 2 you take, you got again 5, so 5 means sp3 dehybridization, right. So if it is sp3 dehybridization, what I can say? Xenon trigonal bipyramidal geometry, but only 3 bonds can be formed, like 1 oxygen, so only 3 surrounding atoms are there, okay. So what happens in this case? Remaining 2 will be out of these 5 hybrid orbitals, remaining 2 are lone pairs and 3 are bond pairs, that's it, okay. So we have 3 positions, 1, 2, 3, 4, 3 equatorial positions and 2 axial positions. So now again, first of all, lone pairs will exhibit more repulsions. After that bond pairs. But which bond pairs? Pi bond pairs. Pi bonds will exhibit more repulsions. After that, normally sigma bonds. Okay. So now again, in this case, you place the equatorial position with lone pairs first. So we have 2 lone pairs. Write 2 lone pairs here first. Yeah, 1 lone pair this side, another lone pair this side. And after writing that, we have oxygen, which is a divalent atom which can form pi bond right now. So where can I place that pi bond? In these axial positions or equatorial? We know pi bond exhibit more repulsion than the sigma bond. So place that pi bond in this equatorial position. Therefore, we can avoid the repulsions between sigma bonds and pi bonds. Okay. And after that, here you have fluorine, here one more fluorine, that is it. This is the perfect structure. They will give 4 different structures that are possible for xenon, and they will ask which structure is more appropriate for XeOF2 molecule. Okay. So this is how you need to answer the question. Hope this is also clear. Right. Let us move forward with few more examples. Yeah. Let me show you some questions so that look at this, all these are JEE mains question, previously asked JEE mains questions. Tell me what could be your answers for each of this question fast. Give a try everyone. See, very simple question, right? Look at the first one. The number of lone pair electrons on the central atom of ClF3, NF3, XeF4, SF4, XeF4. ClF3 means 7 plus 3 by 2, 10 by 2, 5. 5 means trigonal bipyramidal geometry, sp3d hybridization. 5 means out of the 3 bond pairs, remaining 2 are lone pairs. So 2. Lone pairs here in this molecule is how many? 2, 2, 2. Okay, first option you can remove. NF3 having how many lone pairs? Like nitrogen 5, monovalent atoms, fluorines are 3 by 2. 8 by 2, 4 means again 1 lone pair and 3 bond pairs now. So 1, 1, 1. Next, XeF4 we did just now before this. So it has 1 lone pair. So 1 lone pair here and here. Next, XeF6, 2 lone pairs now with octahedral geometry. So here we have 2 lone pairs. So option C will be perfect answer for the question. Next, look at the next question. Hybridization of central atom in BF3 SnCl2 HgCl2. So what is a hybridization in BF3? It is sp2 hybridization. Just you can calculate boron 13th group, 3 plus 3 surrounding atom, 3 plus 3 6 by 2, again 3, that is sp3. So sp2. Okay, so sp2 you got. SnCl2 same, 14th group, 14 plus 2 are the surrounding atoms by 2, again sp2. This is also sp2, and HgCl2 means sp. So sp2, sp2, sp, first option will be your answer. Okay. Next, can you match this again? See, molecules also they are repeating but asking with a different model of questions. Sometimes matching, sometimes shapes or structures, sometimes their hybridization, like this. So they are making themselves, I mean, same compound, same concept, everything is same, but just the way they are asking the question is modified with, see, here SF4 is given here also. Here also again SF4, ClF3 given here, again ClF3 is given here, XeF4 given here, same XeF4 present here. See they are asking lone pairs present here, they are asking hybridization or their shape here. The next question might be hybridization, that's it. So make clear with the concept, first be clear with your concept, then everything comes to you. Okay. So it's very easy. When it comes to chemical bonding, it is very, very easy, and you can gain maximum marks from this chapter. Okay, there can be 3 questions possibility for JEE mains, EAPCET there are maximum of 3 questions from this chapter. Yes, all those are very easy. Okay, two questions for sure Definitely you will get that. The third question depends. Okay, hope this is clear. Whatever I am discussing, tell me XeF4 means seesaw, ClF3 means T shape, and BrF5 is what? See, Br 17th group, so 7 plus 5, 12 by 2. Okay, so 6 we got. 6 means what? Octahedral geometry should be there, but how many surrounding atoms are there? Only 5 are there. So out of that 6, one position is occupied by lone pair. So it becomes what? Square pyramidal, right now. So square pyramidal geometry we have C with the fourth option. XeF4 octahedral geometry with 2 lone pairs becomes square planar. That's it. That's it. Everything is matched here. So A3, 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 B2, B1. So fourth option will be your answer for the question. Hope this is clear. Guys, those who are watching this live session, if you have any doubts or any difficulties in understanding, just write in the chat box. I will discuss once again. Even it is slow, no issues. I am considering that most of you got what I am discussing here, right? Yes. If everything clear, just click on the like button, guys. Okay, right. Look at this question. Identify the set of molecules in which the central atom has only one lone pair of electrons in their valency shells. So tell me, in which element, which molecule they have only one set of lone pair, only one lone pair in them. BrF5, yes, 1, SF4, 1, SnCl2, 1. Why? Because Sn belongs to second group now. Fourth group element na carbon family now. So carbon family, 4 valency electrons should be there. Out of that, 1 chlorine, 2 chlorines are over, remaining one is lone pair. That's it. So 1, 1, 1 will be your answer. So first option will be your perfect. If you want, you can check for the second. See, this is 1 for BrF5, but XeF4 means 2 lone pairs now, so this is not the correct one. Next, XeF4, again this is not the one. ClF3, this is not the one. This is not the one. ClF3 is there. So first option. Okay. See, within seconds you can able to answer this, right? Next, number of lone pair electrons on the central atom of BrF5. How many we did just now? We have did 1. And xenon. See, whenever we have XeO3 molecule, what you will be taking here? Xenon, right? 18th group element, 8 valence electrons. There is no monovalent atom, divalent, do not consider, just take by 2. So it will give 4. So 4 means sp3 hybridization. sp3, 4 bonds should be formed, 4 orbitals are there, but only 3 atoms are there surroundings. It means there will be one lone pair electron. That lone pair electron here we have as 1 here, okay, and here also 1 and 1. Next, SO2, 6th group element now, 16th group element now, so 6 valence electrons. Oxygens monovalent, do not consider, okay. So if you want, this is the second model of doing this same question. So 1 oxygen, 1 oxygen sulfur, remaining is 1 lone pair. So again in this also we have 1 lone pair, so all of them are 1, 1, 1. So option D will be your perfect answer for the question. Hope this is also clear. Next, look at this. The hybridization change seen in where there is no hybridization change is seen. Okay, there should not be any change in the hybridization in the given reaction. See, ammonia sp3, ammonium ion also sp3, no change. BF3 here sp2, but here BF4 is sp3. So there is no change in first option, and here it is tetrahedral sp3. Here it is this is pyramidal geometry with sp3 hybridization. This is trigonal bipyramidal. So hybridization changed here. Again here also changed. So only option 1 will be your perfect answer for the question. Hope this is also clear, right? Next. Guys, look at these other questions. Look into this ClF4 minus, like iodine intermolecular interhalogen compounds here. So tell me, 17th group element, 4 chlorines are surrounded and minus 1 charge is there by 2. So here 8 plus 4, 12 by 2, 6 means sp3d 2 hybridization, AR. Next, NO3 nitrogen 5, negative charge is there, plus 1 by 2, 6 by 2, 3 sp2 hybridization, PCl4 plus. See, what will be your answer? PCl4 plus means 15th group element 5, halogens are 4, positive charge is there, remove -1. See, you need to take this number only if the given atoms are monovalent. Monovalent means they should form only single bond. If they are like oxygen, they are divalent now, so it forms 2 bonds now, 1 sigma 1 pi, so do not take that. Okay, so that should form single bond with the central atom, then only we can consider it as into this formula calculation. Okay, so 5 plus 4 9 minus 1 8 by 2 4, 8 by 2 4, that is nothing but sp3 hybridization. So like this XeSiF, see silicon, which group element it is, which group element it is, we have 4th group now, yes. Okay, so 4th group with 14th group with this 6 fluoride ions and with -2 charge. So you can do this or directly match as per the given option A or here we have. Next, only one option is having AR, so that will be your answer directly, and B S, next C P, then next Q, T it is mentioned, okay, D it is mentioned as T, so it is option D, mostly it will be option C only. Okay, so this will be your answer for the question. Okay, right. Next, let us move forward. Look at this, the correct pair of species which are not isostructural. So isostructural means, see, if they are having same structure, then we can call them as isostructural. So now look at the options, PF6 minus. So phosphorus is central atom here. So phosphorus is central atom, so 15th group 5 electrons plus surrounding monovalent atoms are 6 and -1 charge is there, add that. Okay, you got 12 by 2 6, 6 means we will get sp3d2 hybridization with octahedral geometry having 6 valency electron, 6 surrounding atoms, so octahedral structure. Even SF6 also having octahedral structure. So first option is isostructural, both of them are same structure. So in this second option, if you consider IO3 is there, IO3 means 17th group element na iodine, 17 plus 7 plus 1 8 by 2 4, so it means tetrahedral geometry, sp3 hybridization with tetrahedral geometry having one lone pair, that gives it to be pyramidal shape. Okay, and what about this Xe, same like 18th group element, 8 valency electrons by 2 if you do, we will get 4, that is also sp3 hybridization having pyramidal geometry, because out of these 4, 3 are bond pair, 1 will be lone pair. So both of them are having pyramidal geometry. So this is also isostructural. They are asking for not isostructural. So these are also isostructural, but if you see this one, it is having square pyramidal, but this is having square planar. So these are different structures. So option D will be a perfect answer for this question. Next, bond angles in this second question. Tell me, what are the bond angles? First of all, find their hybridization. See, SiCl4 tetrahedral, BF3 will be trigonal planar. Okay, it means 120 degrees, here 109 degrees, 109.5, and this is sp hybridization 180 degrees, and SF6 there will be having octahedral geometry with 90 degrees and 180 degrees. Okay, so but most correct answer for this is maximum for BCl2. Okay, where do we have BCl2 in these two options? Okay, and in these two options. After this, BF3 should be there. See, yes, BF3 is there, and SiCl4 next to this one. So option D will be your perfect answer for this question. Okay, hope everything is clear, that whatever we are discussing here, right? Right. Let's move forward. Match them again. We did this already. This is also done, right? Next, we have few questions. Again, whatever we did in the previous example, based on that we can solve this question also. See, the number of lone pairs, this is for you as a homework question. because this model questions we did already. See guys, I have almost taken some 15 to 20 or more than that questions are taken, all of them are PYQs. I hope you have seen all these questions very effectively and you got complete concept involved in that right now. So right, if you like this complete content whatever I have discussed, just click on like button and you can share your feedback in the chat box and you can share with your friends also, okay. Right. Can you answer me this first question? Bond angles in the molecules like SiCl4, SO3, ammonia, HgCl2 are given. So for HgCl2 I told you sp hybridization, it means 180 degrees. Next, ammonia and SO3 if you observe, ammonia is pyramidal 107 and SO3 6/2 3, so it will be having sp2 hybridization for SO3, this is for HgCl2, so this is 120 and after this SiCl4 having tetrahedral geometry with sp3 hybridization 109.5 degrees, that is it, we got the answer. So last option if you observe, we have the same whatever we have did, HgCl2 maximum angle, then next okay SO3. So I will tell you one trick here, see maximum percentage of S character greater will be the bond angle. See where do we have maximum S character here, see S character and P character 50-50, so more S character more bond angle, okay. Here it is 33.33% only for S, so as S character decreased angle also decreased, see S character decreased here from here to here, angle also decreased. See further S character decreased, it is becoming 25%, therefore angle further decreased to 109.5 degrees. You can remember in this way. So find hybridization, wherever you got more S character, there it will be having maximum angle, okay. Next, can you do the hybridization in these molecules? Yes, you can do, because we solved these model questions in the last questions, I mean last slides, okay. And here if you observe, we have a concept of dipole moment. So dipole moment can be calculated using formula dipole moment. It is a vector quantity indicated with the symbol mu, written as charge into distance I can say, okay. So yeah, distance means here you can take bond length between AB molecules. If I ask dipole moment, so their bond length you can take here, okay. And one more thing, it's a vector quantity I told now, so it means if I take something like this, I am taking 4 different molecules for understanding purpose. I am taking methane, so methane will be having tetrahedral geometry now, right, like this. So whenever you find a hybridization, first find hybridization. If the hybridization having like something like a fixed hybridization with all surrounding atoms are included, it means all the valencies of that hybridization should be satisfied by the same atoms, then we can say that molecule will be having 0 dipole moment. So in this case methane is having sp3 hybridization with 0 lone pairs, all the surrounding atoms are same, then mu will be equals to 0 in this case, because the dipole moment will be cancelled out in this case, because all surrounding atoms are equal. Similar to this, even if I take SiCl4, see whatever may be the central atom, surrounding atoms are same now, with having tetrahedral geometry, that means 4 surrounding atoms are required, yes 4 are there, then its dipole moment will be 0. Hope this is clear. Next, let me take ammonia molecule. Ammonia you take, what happens in this case, we know nitrogen atom is more electronegative, so that will drag the bonded electrons towards itself, even from hydrogen atoms same side, and this lone pair also tending more towards upside. Therefore dipole moment is completely moving upside now, like polarity will be there, So maximum dipole moment will be seen in NH3, and when we compare with NF3 here, see here fluorines are more electronegative than nitrogen, so fluorines will drag themselves the bonded electrons, and lone pairs are moving upside, always lone pairs towards themselves only. So they will be cancel outing each other to some extent. Okay, therefore dipole moment of NH3 will be greater than NF3. And see BF3 molecule is given here. See BFF. What is the hybridization of boron in this case? sp2. sp2 means 3 hybrid orbitals. All of them are satisfied with same atoms around where there is no lone pairs on it. Therefore, the magnetic like dipole moment will be here 0. So BF3 0, B1. Next what I told you, in case of NH3 and NF3, NF3 is cancelling out, so it will be 2. So where do we have B1, B1? Next what I told you, D2, D2 here, so option 2 will be our answer. Okay, so A4, D, B1, C3, like that you can answer this. Hope you got what I am saying here, right now? Next, even in aromatic rings they will ask like this, they will mention it like this. Okay, so whenever there are same type of groups on benzene ring, what I am saying, whenever there are same type of groups, like we are calling them as electron releasing groups and withdrawing groups now, if that groups are same, then this will be the order. You just remember ortho, meta, para. This is the order of dipole moment, mu. If these two groups are not of same, different nature, like one is electron withdrawing, one is electron releasing, then it becomes PMO. This is the order of the dipole moment in case of different groups. If G and G dash are different, what is this G, G dash? One is attached here, another one might be anywhere, G dash. Okay, it ortho, para, meta might be attached. If these are not same, this is a scenario. If they are same, this will be the scenario. Okay, hope this is clear. Now based on this, you just answer me what will be your answer for CH3NO2, CH3NO2, CH3NO2. Okay, see here alkyl groups are releasing groups, electron releasing, but these are withdrawing, electron withdrawing. So tell me what will be the order out of these 3 compounds which is having maximum dipole, minimum dipole. If you know the answer, if you got this concept, look at this, I have already mentioned everything here. Based on that you can easily answer me 1, 2, 3 what is the order of the dipole moment for this 1, 2, 3 molecules. Okay, right. Next one is hydrogen bonding. We need to study about hydrogen bonding. Let us make it clear here. See, hydrogen bond will be seen when an hydrogen atom, it is attached with some electronegative atom like nitrogen, oxygen, fluorine, like this. Okay, and this hydrogen which is attached with the electronegative atom, and one more electronegative atom should be present like oxygen, something like that. Okay, let me finish it, then you will get more clarity. So some G group attached here, so this G group must be electronegative atom, this must be electronegative atom. So now what happens, due to the electronegativity difference between nitrogen like electronegative atom and this hydrogen, so that generates a dipole here, partial positive charge, because electronegative atom is more drags the electrons now, it creates partial negative and partial positive charges. Same story here also, our electronegative atom negative and this some other group will be positive like this. Okay, so now what happens, there will be electrostatic interactions between the hydrogen atom and this group G right now. So this is what we are saying it as hydrogen bond. So due to this hydrogen bonds, what happened, this molecules will come closer, okay, and that will be having partial bond character here, I can say, okay, right. So it is a purely electrostatic force of attraction between an hydrogen atom attached to an electronegative atom with another electronegative atom, that's it, okay, right. It's a bond electrostatic force of attraction present between hydrogen atom that is attached to the electronegative atom and another electronegative atom. So this, due to this reason, water is in liquid state, because if you consider water molecules like this, see, hydrogen atom attached to the electronegative oxygen atom, therefore it generates negative charge here, partial positive charge here, and in this molecule also negative charge on oxygen, positive charge on hydrogen, right now. So due to this reason, what happens, see, between this electronegative atom and this hydrogen atom, there will be electrostatic force of attraction now, because both oppositely charged. So this results to form hydrogen bond, okay. Now my question, a water molecule can form maximum of how many hydrogen bonds? This is a previous year question. A water molecule can form maximum of how many hydrogen bonds? Look at this, we have oxygen atom with 2 lone pairs now, so we can make a hydrogen bond with this side 1 lone pair with 1 hydrogen atom, this is 1 hydrogen bond, and this side also 1 more hydrogen bond, like this, okay. So if we take water molecule like a beaker of water, there will be different n number of water molecules, right, right. So these hydrogens also make hydrogen bonding this side and this side. So water molecule can form maximum of 4 hydrogen bonds. How many? 4 hydrogen bonds. 4 hydrogen bonds. Remember, this is a question asked previously. Hope this concept is clear, right. Let me give you few more examples with applications. Now they will give OH, NO2, OH, NO2. They will simply ask boiling point order of these 2 compounds, which is having maximum, this A or B, what is the order of their boiling point, okay. So simply remember here, due to the presence of this nitro group and OH group, which are in this way, so there is hydrogen bonding here, and there is no such hydrogen bonding, see, in this we are seeing within the molecule there is a hydrogen bond. We can call this as intramolecular hydrogen bond, okay, intramolecular hydrogen bond. But in this molecule there is no such, because OH and NO2 are very far from each other, no, there is no intramolecular hydrogen bond. But again, you just consider you have a beaker of this para-nitrophenol. So in that we will be having n number of nitro compounds, para-nitrophenols, right now. So there will be hydrogen bonding between this nitro group and another molecule OH group. So this kind of, if the hydrogen bond is between 2 different molecules, see, this is one molecule, this is another molecule, then that is called intermolecular H bond, okay. So this is within the molecule, right, see, within the molecule they are forming. So this is intra, that is inter. So now due to intermolecular hydrogen bond, see, due to intermolecular hydrogen bond, what happens, molecules comes close and they have strong intermolecular force of attraction between them. Therefore the temperature required to convert liquid to their gaseous phase will be very high, because we need to separate them now, because of their high intermolecular forces. The boiling point, therefore this reason, the boiling point of molecules having intermolecular hydrogen bond will be greater when we compare with the intra, because within the molecule we have hydrogen bond. So this molecule will become like a sphere, like will become closer, therefore easily goes out from the surface now. Therefore its boiling point decreases, its boiling point increases. Therefore I can say boiling point of B is greater than A. This is the best application of intra and intermolecular hydrogen bonding. Hope this is clear, right. Guys, if these things are clear, just tell me clear in the chat box. And see guys, we are coming up with free live sessions every day. Okay, except Sunday, we are almost coming live on every day in weekly 6 days for all the subjects, physics, chemistry and bio along with mathematics. Okay, so right, if you are really interested to prepare for your upcoming EAPCET, definitely you can use this classes very effectively for your effective preparation. And if you have any concerns regarding your preparation, just feel free to write in the chat box. We are going to discuss about them in the upcoming sessions. Okay, so thank you for watching. Stay connected with this NEET World channel. In the next session, we are going to discuss about molecular orbital theory and what are the other topics which are from this chemical bonding are there. We will cover in the next session. Okay, along with the PYQs. Okay, right. So hope everything is clear. So thank you for watching.